So, we know we learned many concepts till now. We learned Ansible for configuration management, and then we learned Terraform for infra, and then we learned Jenkins for CI/CD pipeline, CI pipeline at least. So we know all these concepts. Now we need to make them as a standard. Okay, so learning technologies anybody can do. Okay, so we can learn Jenkins, we can do it. We can learn Terraform, we can do it. We can learn Ansible, we can do it. But keeping them in a proper way for an application deployment with proper CI/CD process is very important. So that's where actually we all fail in the interviews as well as in the work. Okay, so we need to understand what is the best process to deploy the application from development to production. So as automatic as possible. Okay, so 100% automation is not possible in VM deployments, but we will try our best to make it more automatic. Okay, so then the legacy, obviously VM deployments is a legacy process, but we will try our best to make them more automatic. Okay, so as part of this process, we need to learn Git now. So, okay, this is very important because this is where our source code management is there. So till now we are working on master branch. Okay, so we should not touch master branch generally. Okay, so we need to find a way. What is our branching strategy? This is the main question. So generally we will be asked in interviews. Okay, what is your branching strategy? So this is the question everybody will ask in the interviews. So while you are telling the answer, so you have to tell how you create branches, how you create, how you merge them into the master branch, then how can you deploy the application into development, and how can you promote the application to the production. So if you are able to explain this process, then it is very good. You will have more advantage to get selected. Okay, and this is the work obviously we do in our daily life. So how developers create the feature branches, how they merge them into the master branch, how can we manage the CI/CD pipeline deployments, how can we promote the application from dev to production. This is the important topic. So as part of DevOps. So that's what we are going to learn now. First, we need to understand Git. What is Git? So we discussed it is source code management. Nobody wants to keep the code in generally in local. Okay, but we want distributed version control system. Distributed version control system. So you know the meaning of distributed already. We discussed earlier. Okay, instead of keeping the copy in a single system, we can keep the copy into multiple systems. That is local and then remote. So we have these two terms. Local is nothing but our computer. Remote is nothing but our central, like GitHub or GitLab, Bitbucket, anything, any Git implementation. Okay. So generally what we are doing, we are creating or modifying files, and then we are adding to staging area, and then we are committing. So this into local, actually committing into local repo, and then pushing changes into central repo. Okay, so this is what we are doing till now. So, but we don't allow the changes into the master branch. Okay, so let us understand this process, how the branching strategy will be implemented. So let me create one repository. Git practice. Okay, making it as public. Create repo. Okay, so I created. Okay, so this one. What I do here is I will go to git bash. See, creating one directory, make directory, like team lead. Okay, for today, just understand me as a team leader. Okay, so I'm just cloning here. Practice it, making master as a main branch. It branch hyphen m master, and then let me create some file here. So let us open this notepad. Here is team lead. Git practice. I will create one file that is readme.md. Opening notepad. Git practice. It just created one file. That's it. Nothing much. And then I'm pushing this. Git add. Git commit. First commit. Git push origin master. Okay, so this is the first commit. So now we want this branch to be protected. Let us understand. Okay, this is a new project, right? This is the new project. Few developers are joining. Few developers are joining our project, joining to our project. Okay. We don't want changes into master directly. So why we don't want changes into master directly is master always points to production. Okay. So this is as simple as when you have very crucial file in your system. If you want to edit it, obviously we will be scared to edit. So what we take, we'll take another copy, edit that, check once again, and then make it as main. Okay, this is the general way, not only Git. So if you have any crucial file, if you have any crucial thing to do, you have only one chance. So what is the way you have to do it? You have to create another copy, do it properly, test it. When everything is good, then you will make it as a main thing. Okay, so this is the general practice, not only Git, anywhere in our life, right? So the same way here, your master is always pointing to production. Okay, you are not allowed, or it is not, you are allowed anyhow, but it is not good to do directly changes into the production. So what we do generally, create another copy, do the changes and do some checks. If everything fine, then merge into master. Okay, so this is the best practice in source code management. That's what we are going to do here. But as a team leader, I need to do some settings. So go to settings here, and there will be branches. add branch protection rule. Okay. Branch name pattern. If it is master branch, request a pull request before merging. Pull request is nothing but, so we will review what are the changes that we will see that anyhow. Require pull request. At least one person should approve. Generally in projects, you can take two members, and then okay. So these are the minimum settings. So in master branch, you are not allowed, no one is not allowed to push directly, even team leader also. Okay. So what I'm saying here, require a pull request before merging. So you should not do any changes directly into the master branch. That is the setting I'm doing here. Create. Okay. And then what I do here, I will add another person as a developer. For example, this guy, tech call with Siva. Okay. 1 second. Just verifying this. System. So now what I'm doing here is I'm making him as a team member. Okay. Add people, tech role with Siva at Gmail. Okay. So I'm giving right access. So now I'm adding him as a team member. Now should get some invitation. So I got some invitation in email. Actually, I'm accepting this. Checking this email. In this invitation. Here. So I got invitation here, accepting this. So now this guy is a team member. Okay. So now I'm cloning this code. I have my authentication key added. So you can check here in settings and then password and authentication, SSH keys. Here is my authentication key added. You can just check here. So inside this dot SSH. Okay. So this is my generally whatever we are using for this. Okay. And this is my another account. Okay. But I just gave -t. So now I need to clone this as a member. I'm just taking another session. So inside here, I'm creating one directory that is team member. Here I'm cloning it clone, but this is the URL I have just configured as -t. You can see this here. You cannot give same host every time. So you are managing multiple GitHub accounts, then you have to give something different here. Okay, at this place, host. And this is the key, private key. Okay. So now I'm a team member. CD git practice. Now, no one is allowed to do any changes into the master branch. As a team member, I need to create another branch. So what is the command here is git branch feature one. I'm creating feature one. Now, if you say git branch, so you got two branches. Now I want to move to the feature one branch, git checkout feature one. Okay. So now I'm into feature branch. You can say this. To create new branch, git branch and then branch name. To move to that branch, git checkout feature one. This is the command, simple commands. Now you can do some changes here. Now, let us go to that team member, git practice, and open this README file. Hi, a team member is doing this commit from feature one branch. So this is the one I just added some code. Just imagine this as a code. So now you need to push git add, git commit, like commit feature one and then commit one. Just for a checking purpose, I'm sending message like this. Otherwise, you have to add meaningful message. Git push origin feature one. Okay, I did the changes. I sent it. Now you can see git log. So I got one commit ID, and this commit ID is from master branch. Now let us just simply draw a diagram. Draw.io git. So this is our master branch commit. You can see master branch is pointing this one. This is master branch. This is the commit. Okay. And from here, I created feature branch. And feature branch moved forward with another commit. The feature branch, let us make it as this color and this color. Okay. When you created here, this will be the one. And now we move forward and the commit ID is this one. Okay. So what is this commit ID generally is? Now let me go to here. So this is 40 characters. So this is 40 characters. We call it as SHA code. 40 characters SHA code. Okay. So you give any content, for example, git hash object, and then give some content. Hello, my name is Siva. Hmm, let me just show you content. This is not important, just a subject. I'm telling you what happens behind the git comment for text. Okay. So echo, hello, I am Siva. I'm just giving this content. Pipe git hash object std input. Um, The options log object, write object, std. So I'm doing that. Okay, so I'll save some file. Echo, hello, I am Shiva. Some sample.txt. Okay, and this one git hash object, and this command stdin paths or hyphen path equal to sample.txt. Put it into the file. This is what I'm doing actually. stdin should not, it should print the code actually. So the problem is here. And thank you so much. Let me see. Okay, so this is the code. So this is the key actually, how Git stores here inside the one. So this is the key and this is the value. So not only Git, any version control system calculates a universal unique code for a content. Okay, so this is the content. So this is the code calculated by Git. So we don't know how it calculates. This is generally from the mathematics. So mathematical algorithm, Git have one algorithm to calculate the code for the content. So not only this small content, you give like thousands of line or millions of line, Git is able to calculate a code for this. Okay, so now if I want, it is universally same. If you give the same content in your system also, you will get the same code. Okay, so here same content, same code. In any computer in universe. If I change a single character, or at least the case, like instead of small s, I'm giving capital S, the code is changed. You can see this. So what you have to understand here, if you do a simple change, like entering one space, entering one line, keeping a dot, keeping a comma also, the code will be changed. Okay, so that is what here it is doing. Now, as a team member, and I did some change, it logged one line. So when you do a simple change also, you will get a different code. Okay. So first few characters is enough generally. No need to enter all characters. This one is enough. So now I'm keep on changing something that is, this is feature 1, commit 2. Okay, I added another thing. Now if I just add and then do it, commit 2. So now obviously I changed some code. So I will get different commit ID. Now you can see git log one line. So I got different one. So I got different one. Now I'm moving forward actually. So this is the commit ID. So similarly, I'll do one more. Just add another code, feature 1, commit 3, add. Now you can see git log one line. This is the one. So it means you did some changes. Now I did some changes and then I moved forward. Now I want to merge them into the master branch. How can I do that? I cannot do it directly. So now there is a way here, that is pull request. Okay, so now I'm the team member. I'm coming here. This is GitHub practice. Git practice. This is for the one I have the access. Okay, so now you can see you have two branches, feature 1 and master. Now what I have to do, you can see here, feature 1 had recent pushes, compare and create pull request. Click on this pull request. So now what you are saying to your team, I am merging the changes from feature 1 to master. You just write something here. Feature 1 changes into master. This is the pull request you are doing. Okay. Hi, I developed feature 1 and it is good to merge with master. Yes, this is what you are writing, and then create pull request. So it means you are raising a request to pull your changes from feature to master. Okay? And what it is saying, review required. At least one approve request is at least one approve is required. So you raised a pull request. Now this request will go to all of your team members. Okay. Now we have another team, that is this one, team leader will come here, and then he will open the pull request, and he will open this, and he will understand what are the commits and what are the changes. Okay? You can see file changes here. So now he will see these are the newly entered. Okay. Now if you want to mention something, so you can add a comment here. Why is this line added? Is it really necessary? Anybody in your team, they can add some comments like this. Okay. And then, so he is sending something. Okay. Why is this line added? Is it really necessary? Now the person who did changes, so generally they will come here, and then they can see pull request, and here sure. There should be some comments here. Yeah, this is the comment. Let me delete this. This is not the way generally. Okay, so let us first go in a happy path. So this is the content we have seen, and now review changes is here. So this is the team leader account. Now he will come here, add your review, and then review changes, and you can see approve. Everything seems good. Approving this. This can be team leader or team manager, anybody. Okay, and then submit review. So one person approved the changes you did. Generally, you can do the setting like 2 members, 3 members should approve before merging. But I don't have 2, 3 members right now. I'm going with one person. Maybe one session I can add you guys as collaborator, and then we can test it. More. You can test this more. So yes. So this team member approved the pull request. So team member or team leader, whoever it is. Okay. Now this guy, whoever did the changes, you can see the pull request got approved. Now he can merge the pull request. Okay. So let us understand what are the things here. Create a merge commit. So this is the first strategy. I'm just clicking on this merge pull request. Confirm merge. So now here, if you see into master branch, we got the code. Hi, a team member is doing this commit from feature one branch, feature one commit to feature one commit three. So we got the changes. So now what is the process? We'll just write it. As a member, create feature branch, do changes, raise PR. Okay. You can ask your team members to review. Once you get approval, so they will be saying a lot of changes. We need to do those changes also. This GitHub UI is a little bit new to me. So we generally use Bitbucket. It's okay. We'll see that. You can ask team members to review. Once you get approval, you can merge to master. Okay, so now if you see the commits here, there are 5 commits, and now these are the commits we did anyhow. Feature 1, commit 2, feature 1, commit 3. You got a new commit. You can see this is the ID. So now this master will move forward. Now master is here. So this is the feature branch, and this one will get into the, all these commits generally will get into the master, and you got another commit, that is this one. And just make it till here. Okay, so now these commits are also, this is the general thing. Okay, so this is the diagram. So now if I just open this, git clear, now I will pull it, git pull, or git pull origin master. Now you can see, so you got some changes into the master branch. Now I'm checking git checkout into master branch. Okay. Here, if you see git log one line, so git pull origin master, git log one line here. Now you can see you've got these commits 8C, 6C, 63. So 8C, 6C, 63. So now if you just type git cat object cat file, you don't need to understand this hash object and cat file. Okay, cat file hyphen. So now what is it saying? It has 2 parents. So this commit ID has 2 parents. One parent is 09C45, 09C45, and another parent is 0FC111, 0FC111. So I am showing this is, you will get a very popular question in interview. What is the difference between merge versus rebase? So that we are going to discuss. This is the merge strategy. So this is the merge strategy. So in the merge strategy, the changes from your feature are merged into the master. So to make this as merge, your GitHub is creating one new commit ID. Okay, so let us understand this. merge. So when we did merge, we will get new commit ID depicting the merge. Okay. And the history is preserved. History, how is it preserved? Anybody can cat file this commit ID, and then it will show us. It will show us what are the parents. Now here it have two parents. Now if you say this one, if you take this one, git cat file -p, now you can see it got another parent 52099. 52099. Now if you go this one, 52099 git cat file -p. Now you got another one, FAA0. This is the one. So it means your merge can preserve the history. Okay, at any point of time, you can go through this commit IDs to understand where it really started. Okay, so this is the merge thing. Now let us understand another one that is called rebase. So now I'm developing feature 2. So what is the better strategy generally? You should always pull before push. This is the line you should remember. Okay, always pull before push. Now I pulled already. Git pull origin master. Okay, so already up to date. Now I'm creating another branch, git branch feature 2, git checkout feature 2. Okay, so now I'm developing feature 2. Now opening this. Just mentioning it as feature 2. Okay, feature 2 commit 1. Okay, I did some change. Now I need to push it. Git add feature 2 branch and then feature 2 commit 1. To add new line here. So new line in treatment. Just adding new line and then pushing the changes. Now you go to feature 2 branch here. Now you got the change. Now I want to do another change. So you should imagine a developer is doing changes like this. Okay, feature 2 commit 2. He is doing some development. Now we will do anyhow with our catalog. Feature 2 commit 2. Now refresh is getting the changes here. Now another one he will do like 3 changes. So now what we did, so let us just understand the diagram. From here, we created another branch. Now you can see git log. So now master is at this one. From here, we created feature 2 branch. Now let us see. We created another branch. This is feature 2. And then we are moving this forward. So we got 3 commits. 1, 2, and then 3. So these are the commit IDs. Okay. So now I want to raise a pull request. Okay, now I want to raise a pull request. Now as a member, I go here, go to pull request, and then new pull request from feature 2 to the master. Okay, create pull request. Feature 2 is developed. Please review. Create pull request. So one of the team member created pull request. All other members should go, and then they have to review the changes. Now let us go to the pull request here. We got this one, and here generally we can do the comments from here generally. So check once again and then comment it. Now he will go and then see we got this comment. He has to reply for this and then code reply. Yes, check once again. It seems good. So the history will go like this. So they will ask something, he has to do something. And then again he will come, again he will write some comment. So few more code is missing. Add, for example, forgot password feature 2. So then he will come and then he will do another change and then he will push it. So now we'll come here. Again, he will say, added that feature you asked. You just imagine this is how it goes into the real time. Okay, generally in our projects, our developers will do like this. Okay, now you can see 4 commits are there. And these are the files changed. Now our team leader or our team members are satisfied. They will come here and then they will do the approve, add your review. And here you can say approve. Everything is good. Approving. Okay, submit review. So now this is done. Now let us come here. So this is our team leader. He approved it already. Now we can say our team member, he will come, open pull request, and then You can see merge option, but here this time we will see different thing. Rebase and merge. Okay, you can see this rebase and merge. Confirm rebase and merge. Generally, you can delete this branch. Once it is done, you can delete this branch. But generally in our projects, they don't delete because they are scared to delete. If you know Git very well, you can easily delete it. Okay, you can delete this because we got everything here. Now you can see the commits. So what are the commits here? Let us see the commit IDs 84637. From here, you can see from here, it is 84637. Eight four six three seven 6337, whatever, and then this is the ID. And then this is another ID. And we have another one. That is this. Okay, so this is move forward like this, master branch. So now the commit IDs are changed. You can see here, the commit IDs are clearly changed. So this is what rebase. When we did merge, we will get extra commit depicting the merge. History is preserved through parent objects. But in case of rebase, you can see is any extra commit created here? Just you can send answer in the chat. Is there any extra commit created? Please answer in the chat. Any extra commit created here? No extra commit. And as well, let me pull the changes and then show you. Checking out to the master. Git pull origin master. Git log one line. Double C 8 double C F6. Double C 8 double C F6. Now let me just understand this. Git cat file -p. Now how many parents here? Only one parent. So now it is understanding the parent is 39698p. So now if anybody see this, what they will understand? If anybody see this one, this particular part, so what they will understand here, so they will see this commit ID has two parents. One is this one and one is this one. Somebody through a feature branch developed like this one. But if anybody see this here, there is no pointer pointing to this one. Now they will understand, okay, this is developed linearly. This is the linear one. They cannot understand this is the parent of that. Okay, so that is what the rebase. It will not preserve history. Okay, and another thing, it will change commit IDs. It means it rewrite. Okay, so the difference, this is very, very popular question. If you see the question here, merge versus rebase, generally everybody will just read from the internet or they will buy it from the internet, but they don't know what they are telling here. So if you just click here, the major benefit of using Git rebase is it provides a cleaner merge history. It works linearly, removing the unnecessary merge commits. Unlike Git merge, it makes easier to move along log history and understand the changes. So this is what it is saying as part of the rebase. Now you can understand Git merge two branches to create a feature branch, and say okay. Git merge is comparatively easy. Git rebase is this is fine. Git merge safeguards history. Now you can see this is how it is safeguarding the history. So if they ask how it will preserve the history, you can always understand the history through the parent objects like this. Okay, and what else they are saying? This is fine. Chain like structure. What is this? Chain like structure is this one. Okay, and this is Git rebase forms a linear structure. Linear is this one. And Git merge is preferred when large number of people uses. Okay. Yeah, they didn't mention the complete thing actually. So now you understand anyhow. So Git merge preserves the history. Git rebase cannot preserve the history. Git rebase rewrite the commit IDs and maintains the linear history. Okay, and there are no unnecessary commits in the rebase. When to use merge, when to use rebase, generally it is our understanding. If you want to preserve the history, then go for the merge. If you don't want to preserve the history, then go for the rebase. Okay. If you want to preserve history, go for merge. If you don't want to preserve history, go for rebase. Okay, so generally I use rebase in our projects, but while rebasing, you have to do it carefully. Now let us see one more merge strategy. So these are all merge strategies. Okay. When I'm saying merge strategy, it is like getting the code from feature to master. It can be either merge or rebase or squash and merge. Now we will see that. Merge strategies. Here, what I mean merge is getting code from feature to master. These are the strategies. So inside this, we have seen merge and then rebase and merge. And then now we will see another option, squash. Okay, so what is here is git checkout or git branch feature 3. Git checkout feature 3. And then now feature 3 development is going on. Feature 3 commit 1. Now adding it. Feature 3 commit 1. Now adding another code. Now just imagine like our developer is doing a lot of changes into the files. Feature 3 commit 2. And feature 3 commit 3. So he added 3 commits. Now go here and then go to the feature 3. And then you can see, so we got 3 commits. Now raising a pull request, feature 3, just keep it feature 3 and create pull request. Now our team leader and other team members, they will open this pull request and they will see the files changed. And then just this here, actually, this plus symbol. It's fine. If they want to give some reviews, they can do something here. They can comment here. Okay, and understand everything is fine and they are providing their approval, approve, or request changes something. Request changes is not approve, only approve is approve. Approving feature 3 and then submit review. Okay, now he will come here and then while merging the pull request, he is selecting the third one, squash and merge. Okay. Now, yeah, squash and merge. So what is this squash? What do you mean? Generally, what is the meaning of squash? Combining everything into one. So that is the meaning of squash. So now what it is doing here, it is combining all the commits. You can see feature 3 commit 1, feature 3 commit 2, feature 3 commit 3 actually. It is combining everything into a single commit. Feature 3 as feature 3 and I'm just clicking on confirm squash and merge. Now you can go and see here. So you will see the master and commits. Now you got only one commit. So let us understand through the diagram. On top of this, we got this one. Okay. Let us understand this through git checkout master, git pull origin master, git log one line. Okay. So what it is saying, git cat file -p so it don't have any history, just like rebase. Okay, combining everything into one and then rebase. So now I prefer this one personally, squash and rebase. Why is this? Because a feature, while developing a feature, one feature is developed by one developer nowadays. Okay, because we have 2 week sprint, right? So the sprint is 2 weeks or 1 week, 1 week or 2 week sprint. This is microservices. These are microservices. One feature is allocated to one developer. He may do lot of commits. He may do lot of commits. as part of his development, as part of his feature development. Okay. He may do a lot of commits as part of feature development. So if I don't squash it, what will happen here? You can see this. You will get lot of commits. Right now we are doing 3 commits, but in real time it may be 30, 40 commits. Your master branch will become very big. And if everybody see after 1 year or 2 years, it will have thousands of commits. It is very difficult to go and then check the history generally. So that is why anyhow it is done by one developer. You can always squash the commits as part of one feature and mention it as feature name or number something. Now, if anybody see this here, they can understand, okay, this is feature 3. Before that, this is feature 2. And before that, this is feature 1. So that is very easy. Squash and rebase generally. So yeah, obviously the commit ID will be changed. When you are merging multiple things into the single one, so obviously the commit ID will be changed. Now your master branch is looking like this. This is feature 2 and this is feature 1. Now you can see this is very clean. Now after that, you get another feature, that is feature 4. That one be like this. 1, sorry, 2, 3, 4 like this. So it will be very easy to just see and understand. Now what happened to this commit IDs? This will be garbage collected. So this is the meaning of merge and rebase and squash. Okay, if you know Git very well, go for rebase. If you don't know Git very well, then go for merge. Okay, so that's what they are saying. It is rebase is comparatively harder. It means you have to understand what you are doing. You have to understand the commit IDs are changed, and you have to understand the history is not preserved. And you have to understand I can squash multiple commits into the single commit like this. Okay. So that's what you have to understand. So this is a mandatory question in interview, merge versus rebase. Explain it properly. Okay. Explain it as you have done it. Okay. Don't explain it as you read in the internet. And then definitely there will be no other question in Git. And this is the popular and nobody generally will tell the proper answer. And another popular question is branching strategy. I'm not telling this only for the interview perspective, but this is what we do in our real time also. Branching strategy. What is the branching strategy we followed here? So this is also a question. What is explain the branching strategy you are using in the project. Now you have to say, so we are using master and feature branching strategy. Okay. So we made a protection. No one is allowed to do changes in master directly. Okay. We should raise PR. Minimum 3 approvals we should get. So this is the protection. Okay. So we do changes in feature. Okay. Raise PR and get the approval. Okay. And while merging PR, we choose merge option as our merging strategy. So this is what you have to explain. What is your branching strategy means? What are the branches you use in the feature? Master is our main branch. Feature is our short living branch. Master is main branch. It is long live. Main branch is nothing but long live. Feature is short lived branch. Okay. So once your changes are merged into master, you no longer need this. You can delete this. Generally in our projects, our guys will not delete it, they will just keep it because they are scared. But obviously you can delete. Short-lived is that is the one. Delete this branch. Once your prior is merged, you can delete this. This is the branching strategy. So this is the latest branching strategy. Okay. So there is another thing called Git model. This is too much legacy. Even few projects are using this one, Git model. This one, a successful Git branching model. So this is proposed in 2010. Okay. And then he himself mentioned here, don't use this somewhere. While there is nothing really shocking new to this branching model, the big picture figure that is to be tremendous use of this from elegant novel. Actually, this is the old one. Not very long. Mostly popular. This is what's the popular. And you can see here. You can see. I would suggest to adopt a much more workflow, that is GitHub flow, something like this. Okay. So he's saying, don't use this. This is more than 10 years ago. We got a much more simple model. Okay, but unfortunately, many projects are still using this because they are scared to move to this branching strategy, master and feature. But you can say we are using master and feature, and feature is the short-lived branch, master is the long-lived branch, and then we don't allow anybody to do changes in master directly. We have to raise PR. So our developers will do some changes in feature branches. They will raise PR, and the merge strategy we are following is merge. So because why we choose merge is because it will preserve the history. We don't want the history as per our project requirement. So that's what you can say. Then he will definitely ask, then why don't you choose rebase? Because in rebase, history is not preserved, commit IDs are changed. So our project, the requirement we got is they want to preserve the history, and that's it. So in one question, you answered two answers. Like in one question, they obviously ask while you are explaining this one, we choose merge option, then they will definitely ask what is rebase. Then you explain what is rebase, then that's it. Okay. So and another branching strategy is that is trunk based branching strategy. This is super advanced. So in trunk based, will be only one branch. That is master. Trunk based, only one branch. Only master, only long lived branch. You do changes here directly. But to do this, you should have some advanced technologies, advanced implementation. So if you are doing changes directly into the master branch, you should have a lot of checks. You should have a lot of checks. Before going to production, so you should do a lot of things while deploying into the development and then checking whether it is done or not properly, and deploying into the QA whether it is done properly or not. Doing the testing. Testing should be 100% automation. Okay, no manual testing. You have to do unit testing, you have to do functional testing, integration testing, all types of scanning, everything you have to do it properly. Okay, if you are doing changes in only one branch, you have to be perfect and you have to know what you are doing, and you should have full automation. Okay, full matured automation. So that is what the trunk-based branching strategy. Generally, we don't use in big companies because obviously our clients are scared to do this. Only in very, very technically advanced companies will do this. Okay. So, and whatever we are doing master and feature, that is also very advanced one. So this is nothing but master. Okay. That is the trunk based actually. So whatever now we are discussing is feature branching. Okay. And you can understand the advantages like this. So earlier we had lot of branches. So that is like in a Git model, as said in Git model, master, development. So these are the branches: development, release, feature, hotfix. Okay, when you have too many branches, obviously you should have more maintenance and you should be more careful generally. But if you have two branches generally, so it is simple to manage, but you need to be extra careful. And here a lot of headache actually. We don't know what is happening in what branch. And if you have only one branch that is master, it is even simple, but you should have full automation and full types of testing. Okay, you can say this one in your interviews. You don't tell this trunk base, just tell trunk base is only single branch development. Okay, our clients don't want that one, so they want this master and feature. And another thing, how you get conflicts. So to tell that anybody is ready with your laptop. So when we get conflict, so when we get conflict is, for example, master is here and there will be one feature development. So two persons clone this one. Okay? Two developers. And he will move forward and he will move forward and then he will merge back here and then he is moving little slow here, here, and then here. Now he will try to merge, then obviously he will get conflicts because someone already pushed some changes here. So what he has to do, he has to pull the changes and do something, resolve the merge conflicts, and then he has to push again. Okay, so to depict this one, okay, so let us do this in next 10 minutes and then we can close this session. Okay, so now what I'm doing here is our team leader is working on one feature. Okay. At the same time, another team member is also working on another feature. Okay. So now let us see. So this is our team leader, right? Git full. He's pulling. Okay. He's up to mark. Git log one line. Git full origin master. Okay. Git log one line. Now he is at 873 DF7. 873 DF7. And then our team member is also pulling. He is also at DF this one. Okay. So now our team member is creating one feature, git branch, and then feature 4, git checkout feature 4. What is this? Okay. Now he is doing feature 4. And this guy is also team member, git branch feature 4. Sorry, he's doing feature 5, git checkout feature 5. Okay. So our team leader is very fast. Maybe he's doing the changes very fast. Feature 4, commit 1. Now let us go team leader, git add, git commit feature 4, commit 1, git push origin feature 4. So he's doing very fast development, maybe, or maybe his feature is very less. Changes are very less. Feature 4, commit 2, and then feature 4, commit 3. Okay, he did very fast, and then he will also raise pull request, who's not an exception. Okay. Compare pull request, and then feature 4, he raised pull request, and then our members are reviewing this, and then they will provide their approval. And then he come here and he merged. Okay, he merged. Now master branch moved forward. Obviously it moved forward. Now we can go and check here. Now our master branch is at this stage. Let me remove all this. So after 870, this one we got these many changes. Just understand this is the now master branch is at this stage. Okay. Master branch is at this stage now. So we got another feature branch that was doing. Our team member is doing. Now he will also edit some changes as part of feature 5. Okay. Team member. Feature 5. Feature 5 commit 1. Okay. Now he will push it add feature 5 commit 1. Feature 5 commit 1. Shown here. Git status. We are in feature 5. Oh, done. Okay. He is doing some changes. He's not aware of feature 4. Okay. Feature 5 commit 2. So imagination is very important here. Right? Feature 5 commit 3. He's not aware of that. Another one merged already into master. Okay. So now he will go and then he feel himself, I completed, I need to raise pull request. Okay. And raise pull request. Now you can see cannot automatically merge, but still you can create a pull request. You can see this branch has conflicts. Why are the conflicts is there? Because you write something, another person wrote something and already pushed it. So now Git will compare, okay, at the same lines, I got different code. So this is feature 5 and this is feature 4. Now I don't know how to merge. Okay, if one line, if two different text is available, then obviously we don't know what to merge, right? It will confuse. It cannot decide, it cannot delete this one and it cannot insert this one. Okay, so Git cannot decide if it finds same content at the same line number. Okay, so it's obviously human has to decide what to keep, what not to keep. So now what is the way? So this is also another question. How you resolve merge conflicts. First of all, how you get merge conflicts? How you resolve merge conflicts in your project. First of all, understand when you get merge conflicts. If Git finds different content at the same line number, it can't take decision of merge. Take decision what to keep, what not to keep. Okay. So now what we have to do? Team member. First, he has to check out master and pull the changes. Git pull origin master. And then he will check out his feature branch. And then he has to merge with master. Git merge master command. Okay, now you can see here. So pulling the changes from your master to feature, and it is saying automatic merge fail, fix conflicts. Now you've got some conflicts here. So obviously, so these are the conflicts. Now Git is saying this is your code, feature 5, but I found the same code at the same, I found the different code at the same line number. Now you guys can decide what to keep, what not to keep. Now you and another person who developed this feature 4, you sit together and then you will decide to keep the same. Remove this, and you don't want this change. Maybe you implemented already here, or feature 4 already implemented this one. Now you don't want this, you can remove your. Now you guys can do something. You can take the decision what to keep, what not to keep your code. And now you can see it is saying merging. Now if you say git status, okay, it is modified. Now git add readme.md git commit -m, okay, conflicts resolved between feature 4 and 5. Okay, now you can see It is done. Merging is done. Now you push it. Git push origin feature 5. Okay. Now you can see your pull request. Now Git will understand, okay, these guys resolve the conflicts. Now your team members, generally, they open the pull request and they will review and they will approve. And now you can merge. Just take any merge strategy. Okay, now you see the code is obviously you guys decided what to keep, what not to keep. Okay, so this is how you resolve merge conflicts. So by having this understanding generally on Git, tomorrow, then we will continue our CI/CD process of catalog. We will ask our developers to create feature branches. They do the feature branches. Now they are not allowed to do in master, and they will develop, and then they will go with CI/CD process. Okay, they can stop till here today. Any questions? No questions? Okay, Git is also like a Pacific Ocean. Nobody can understand Git completely. But these are the things we daily use in our projects. Okay, one blind rule is pull before you push. You don't know what happened to the master branch. Okay, maybe 100 developers are working. You don't know what really happened to the master branch, whether it is moved forward or not. You have to always pull and then you can check the merge. Pull always before push. Any questions? So you have to practice this more to speak confidently in interviews. Yes. Sontineni Venkatesh.
Hi, Siva.
Hi.
Actually, what is our role in this Git?
So we are also developing some projects, right? Like our shell scripting, Ansible.
Yeah.
We have to follow the same process.
Okay.
Whoever is working with Git, they have to follow this process. So developers are developing code. As a DevOps and cloud engineer, we are doing our Terraform things, right? We are not allowed to do directly in master. We have to create feature branches and then they will review the code and then they will approve.
Okay. Thank you.
Santosh Aula.
Hi Shiva.
Hi.
Yeah, Shiva, what is the meaning of git revert?
Git revert is that is some damage comments. Yeah, you can remove the previous commits actually.
Okay, git cherry pick also same, right?
Git revert, something you can see the understanding. Git revert means undo. So you committed something, but you don't want the commit to exist. You can go for git revert. So nobody uses this actually. Actually, you should not use this. Practically speaking, if you do some unnecessary commits into the, some faulty code into the Git, you have to always add on top of it another change. Remove it and then commit it. Automatically, it will be removed. Right? Git cherry pick is nothing, but we'll see this tomorrow. Git cherry pick is picking some changes. Okay. So another branch, maybe you want to pick not everything, but few changes, then you can do the git cherry pick. So git revert is obviously to remove the previous comments. You practice till here today, okay, all of you guys, and then understand the way how we work in real time. So tomorrow we will continue that. So there is another popular question: Git revert versus Git reset. Okay, we will discuss that tomorrow, and then we will move to the our CI/CD again. Any other questions? Okay, if no questions, tomorrow again we will create the infrastructure and then in dev, and then we will do the CI pipelines. We will go for dev deployment, and actually it's a lot of work from tomorrow. Whatever we learned till now, we are making it into the practical real time way. Yes, Janardhan.
Yeah, hi Shiva. See, the Git rebase generally we are just rebasing this branch to another branch, right? To the target branch. So how the commit IDs will change in that case?
Commit IDs, that is very deep actually to understand. So this is all. Git is always a reference. Okay, so this is a reference. If you are removing that reference, obviously commit ID will be changed.
So for example, if you see in the bottom chain, like yellow color, so these commit IDs will be rewritten, and
Yes.
the commit
So
hashes will change. That's what I want
the
to say.
commit IDs will be deleted also by garbage collector. So there
So
will be no reference. This will look like this come from here, this come from here, this come from here.
Oh, the commit hashes completely it will change then.
Commit IDs also change. That's what I mentioned here. Different commits you can see.
Okay, it's very difficult then to track like from where the commits happened.
Actually, no
If I
need to
understand.
track actually. So if you keep like this, so what happened is you change from this code to this code. That's it.
Okay.
Why we want to preserve history? It's not required actually. If you are confident. So this is feature 1, this is feature 2, this is feature 3. That's all.
Okay. Okay.
So you have to be more confident on Git to do rebase. So that's what everybody says generally in internet. Merge is easy. Rebase is you have to understand the commit IDs are changed. You have to understand the history is also changed.
Okay. Okay. So garbage collection means like, see, once we rebase, the source branch will be deleted automatically, or is it something?
No, these
It's
commits
little
will be
confusing.
deleted. These commits will be
Commits will be
deleted
deleted.
because they don't have any reference. You can see
Okay.
the
Okay.
chain. The chain is here. This one. If you have the chains, then they will be preserved. If you don't have any reference here, these are like orphan commits. So this will be removed by garbage collector.
Okay. Okay. Maybe on time practical.
Yeah.
Maybe
So
making this more
generally,
clarity.
no need to understand this much low level. Okay, about the Git objects. If you are really interested on Git, yeah. So I have one course in my channel. I taught this in 3-4 years ago. You can go to that. Okay. Yeah.
Okay.
So that's all for today. See you in tomorrow's session. So from tomorrow, yeah, actually, we are going to do Terraform, Ansible, Jenkins, CI/CD together, all the things together to make our pipeline success. Okay. Have a nice day. See you tomorrow. Bye bye.